Welcome to my presentation on interpreted programming languages. I'm going to dive into what they are, what they do, and why people use them. Okay, so first, it's important to start off with what is an interpreted programming language? Well, an interpreted programming language is read by a program written in a higher level language that then compiles the code into machine code. So essentially, what that means is as it reads through your code written in this language, it translates it line by line into machine code directly. And that interpreter is written in a higher level language like C++ or C. Um, as you can see, there's a little illustration here of the process and the workflow of that. So why do you choose an interpreted programming language? Well, there's many advantages and disadvantages. One main advantage of an interpreted programming language is code independent or platform independence. Code can run on any platform as long as it has the appropriate interpreter on it. This can be on any machine as long as you have your interpreter on it. Uh, Another advantage of interpreted programming languages are the dynamic typing. Variables are not explicitly declared, and so that allows for flexibility in the code. When you're writing code in Python, you don't have to declare a string or an integer, it just does it automatically. Some disadvantages are slower execution. Interpreted programming languages you generally are generally slower than compiled languages because they're translated at runtime. So every time you convert it, it goes down and compiles it into machine code right then and there. Uh, it requires the presence of an interpreter on the target machine, so it has dependencies. The general makeup of an interpreted programming language is a lexer, which breaks down the source code into a sequence of tokens. The parser then takes those tokens and organizes them into a hierarchy. Semantic analysis checks for correctness in the code. So basically, it is looking for grammatical errors in the syntax. And the interpreter itself reads the source code line by line and translates it into machine code. So it looks at it one line at a time and translates that directly into machine code. A few common languages are Python, Ruby, Rust, and Perl. There's many more of them like JavaScript or PHP. Most of these are popular in web development, but they also have many applications in games and other desktop applications. Like I just talked about, there's a few pros and cons. It's slower than a compiled language. It's not ideal for an embedded system, but it's mostly just used for desktop applications like games or websites. And there's a little code snippet of some Python. And that's about it. That pretty much sums up interpreted programming languages. Thank you for listening, and hope you have a great day.